Yeah, good evening everyone. Today we are going to present a final project on IoT drive system home. This report was submitted by Madan Kumar and Panduranga myself, and our guiding professor is Su. The outlines of this project consist of the background and introduction, IoT system architecture, research methodology, implementation, and conclusions. Coming to the components that we use in this project, the sensor we use DHT2 temperature, humidity and heat index, digital light. Messaging we use MQTT, Mosquito. Data storage InfluxDB. Google Assistant we use is Google Nest Mini, and for data visualization we use Grafana. Coming to the introduction to IoT, the Internet of Things is a network of physical objects or people called things that are embedded with software, electronics network and sensors that allows these objects to collect and exchange data. The goal of IoT is to extend to internet connectivity from standard devices like computer, mobile, tablet or relatively dumb devices like a toaster. IoT makes virtually everything smart by improving aspects of our life with the power of data collection, AI algorithm and networks. The thing in IoT can also be a person with a diabetes monitor implement, an animal with tracking devices, etc. The system architecture will be like we use in this final project is Node-RED, Raspberry Pi, and Telegraph. For data storage we use InfluxDB, and for visualization we use Grafana. The methodology will be like a Node-RED, Instruct1, Raspberry Pi, InfluxDB, and Grafana. Coming to the methodology, connecting Node-RED and Home Assistant has multiple ways of doing that. The first one way is installing Node-RED add-on on Home Assistant, and the second one is installing Home Assistant Node-RED on Node-RED. For this project, we are going to use the first method, that is installing Node-RED add-on on Home Assistant. Now we are assuming that we have Home Assistant installed on Raspberry Pi and have Home Assistant dashboard open. The implementation of the project will be like this, and the rest will be continued by my friend Madan.
Okay, here we are going to complete the implementation. So we got the Raspberry Pi and then breadboards or connected to the LEDs, and then we use Smart Nora Node for communicating with the Google Assistant. So when we pop into the home, we need to turn on the light. We are tired. We don't want to go to the switchboard and then touch the switch and turn on the light, but we have another lazy way to do that. That is, we are asking our Google Assistant to do that. Hey Google, turn on the lights. Yeah. So we are going to ask the Google Assistant to turn on the light by executing the code in the Raspberry Pi, and then we are going to turn on the devices on. So we need several codes, and then we are using the Google Nest Mini speakers. So this is the implementation as an initial step we have done. At first we have connected the Google Nest Mini and the Raspberry Pi with the Smart Nora nodes. So in order to download the node, we are first going to manage the palette by clicking the menu bar, and then we are selecting the manage palette. Then we are going to download the Nora, Smart Nora, and then we are going to use the following node flows. So we got 3 rooms over here: living room, bedroom and kitchen. So living room has the light, and then bedroom has the air purifier, and the kitchen has microwave oven and the rice cooker. So I'm going to show how to do that. So in the menu bar, we have already turned on the lights. Over here we need to configure the light menu, like we need to configure the Nora nodes. We have to edit the Nora node, and we have to enter the email ID, and then we have to log in, and then we have to enter the name as YZU. So finally, if we want, we can add the two-factor authentication in order to improve the security. And then in the same way with the bedroom add purifier, we can increase the speed by low, medium and high, and also we can give the hint of the room, and then we can select the different languages over here. Yes, with the microwave oven we can press OK or cancel once the food is done. And also with the rice cooker we can prompt with different actions, like we can ask, oh, we can prompt with the menu OK and cancel. Finally we deploy it. So parallelly we are doing the data log with the InfluxDB. We are connecting the measurements as DHT sensor, and then we are using the data logs to be stored in the InfluxDB. Here we can see the ports which is being connected is 8086, and finally we connect the YZU database. In the same way for the bedroom also, we are connecting the database and we are storing the data over here. Yes. So we have loaded the data into the YZU database, and then we store the data in the into the stored the data into the graph InfluxDB, and finally we visualize the data using the Grafana. Thank you. Hey Google, turn on the light.